Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 468 maximum total subarray value 2. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. Honestly, when I first started this one, I looked at the 7 point, right? Let me make this bigger. And I thought that it is going to be a tricky problem. And my initial ideas were thinking about something along the sweep line. And I thought about different variations, right? Meaning that for every number, maybe this number is the max, maybe this number is the min, and maybe I have to go back a little bit, try to figure out. And if it's like the max and the min, then maybe you have to do like some mono stack or mono queue, binary search, a lot of things going on, and I couldn't figure it out, to be frank. Or maybe I could figure it out with enough time, but I didn't like the way that I was going, and it was getting more and more complicated. And the other thing is that I did cheat a little bit in that I looked at the leaderboard. Well, maybe not this leaderboard, but I did look at the leaderboard after like 5 minutes or so, and I saw that some of the top people, yeah, I know some people cheated, but some of the legit people still was able to get it in like 8 minutes or something. So I was like, okay, well, if they're able to get it in 8 minutes, there should be a simpler solution. And that's basically how I started working on this problem. So there are a lot of ways you can think about that, but ultimately, I just thought, well, I think the thing that the light bulb hit for me was, ironically, or maybe I don't know if it's ironic actually, maybe I'm using that term wrong, but for Q2, which I thought was a useless problem, and frankly it still is kind of, but I was like, oh well, I was just thinking about this problem in terms of, well, what is the maximum, like if we think about it in terms of heap type thing, right? Because the most naive idea is this n square thing, create every subarray and then just sort it or heap it or whatever, right? But n square is too big, so you can't really do that. But so I was like, okay, well, what is the max number that we can put into the heap? And it just occurred to me, right? Like I wasn't, like this isn't it isn't some sort of like, oh, all you have to do is think about this and then do that. It was just like, exploring these problems and just trying to figure out how to get to it. And I was like, okay, well, what's the max thing that we can do? Well, of course, it's just Q2, right? Just take the entire way. And I kind of went back to another idea that I had from the sweep line, which was that one of the troubles that I have with sweep line is that as you sweep, it still takes the previous, like if you have, I don't know, the numbers 1, 2, and 3, 1, 3, and then 2, and basically you have a number in between, the 2 extends in a way, the 1 and the 3 and the subarray contribution to the answer, right? So I was thinking of something along those lines. I was like, oh, well, if you take the max answer, which is Q2 of the entire way, and you could just kind of think of it that way. Now you're slicing it off to the from the right and to the left, and then you get smaller subarrays that are almost going to be the max, but I mean not necessary, but almost, right? And I think there is a proof there that's a little bit tricky, but during the contest I definitely YOLO'd in that. Because if you think about this idea of a segment, and as you chop off pieces, the answer actually jumps, right? It's not like a continuous thing, but it just jumps around. So as a result, there's this. I don't know how to describe it, to be frank. So my apologies away. But it's this idea that when you have these big arrays, the bigger they are, well, the more likelihood, if you will, and that the contribution is going to be big, and it's going to be picked, and so forth, right? And that's basically the idea. And I had some ideas around that, and like this idea of dynamic programming, right? So because then now you have one array, you want to chop off the left, you want to chop off the right to get something that's slightly smaller. It doesn't have to be that much smaller, but it could be a lot smaller. But in terms of the subarray, it's going to be smaller, right? And in a way, now let me just add some visualization real quick. Because because the idea here, instead of me going, which is fine maybe, but I want to give some idea. But basically you have this array of like, I mean, I'm just banging on the keyboard. This is random numbers. So if you have used the entire thing, well, and maybe the max and the min is here, right? Okay, let's just put the 1 here so that the max and the min is here. Well, okay, that's too big, so I'm a dumb boy. But yeah, max and the min is here. But this is also, like a sub. So you start with a subarray that takes this. But if you want to know the max contribution that is here, then it's almost like a reverse of the reverse of, okay, well, you start with this, then now you extend it, right, to both direction, and it, and so forth. So then it's almost like a reversal of the reverse of like, okay, now we start the biggest array, we chop off a little bit, right? And it's almost like how do you say it, like a continuous function where you cannot get to the middle of the piece without chopping some piece off, and that's kind of the idea, is that you have this like smooth-ish transition that you have to get. And like, for example, if and if this goes all the way to like here, right, then then you also have to count all the bigger ones, because all the bigger super arrays, if you will, that contains this smallest piece will also have the same answer, right? So then I kind of did this way, and in a way that's how you would sort it, but we cannot generate all the numbers. So then we know that if this is here, then this is going to, one, lead to this slightly smaller piece, but also that this one will always be monotonically bigger than this one, right? Because that's just the idea, and that's basically the idea, is that you just generate all these things. And yeah, and then there is this thing about sparse table. You also use a segment tree, but and honestly, I copied and pasted this from a template that I had. Didn't really think about it. The idea here is that, okay, well, if we let's just say, and this is an implementation detail of me going, okay, well, now then let's start by saying, okay, we want index 08 or whatever it is. Maybe I'm off by 1, right? So then now we want to go, okay, well, 18 and 07, right? So this leads to this, right? And so forth, right? ... So then I go, okay, well, how do you evaluate the score of this? Well, this is just the min of this. Well, the other way around, sorry. The max of this minus the min of this, right? And I was like, what's the easiest way to calculate that? And maybe there is some fancy way of doing it but for this problem, I was like, okay, well, let's just use a sparse table, because that's literally what you can use a sparse table for. You can also use other data structures like segment tree to get a range query, but I was like, oh, sparse table is fast, it's O of 1, so I don't have to worry about it, right? Because after you pre-process everything, which makes it n log n, query should be O of 1, right? I mean, this is just a min of 2 numbers, so it's just super fast, so I don't have to worry about additional timing things. Though actually, I don't know how long this ended up taking. So it still took 6 seconds, so I think that was actually necessary. I don't know if segment tree would have been fast enough, but it would have been correct, is what I would say. And maybe even like actually relatively fast, but maybe just not fast enough. I don't know. And maybe it is fast enough, because Leetcode you can never tell before you actually submit it. I don't have segment tree ready. But yeah, so that's how I come up with using sparse table. Is just I had a question, or like I wrote the code so that I was like, oh, I need to know a range min and a range max, and it's static, so sparse table is good enough. That's it. I plug it in. You can watch the live version, but I just plug it in, and then there's a min version and a max version, right? So we create 2 sparse tables. Start with the 0 to n minus 1 inclusive. The score is equal to 0. We start off with a heap. We set up with a set. We push to the heap. This is the score, right? This is the max minus the min. In Python, it is a min heap, so that's why I had to do a negative so that I make it a max heap. And also show that we've seen this, which I almost forgot and almost accidentally submit. And the idea here is just from DP, actually, right? Like if you go from 04, well, here, and I kind of already did this, but it goes to what was it, 03 and 14, right? But if you draw it one more time, then now the 03 goes to 02 and 13, right? And 14 goes to 24 and 13. And of course, as you see, we do the 13 multiple times. And in this problem, it's not like a shortest path type thing, right? Like we choose the array every time. So that means that we would choose, if we insert 13 multiple times into the heap, it's just going to be wrong for something. So that's why we have to keep track of the things we've seen so that we don't do it again. That's basically it. Otherwise, for k times, we choose the max every time in a greedy way. We choose the max, which initially is the entire array, but you get the score, and of course the score is negative, so we can fix the score. And then again, just shrink a little bit on the left side and the right side if we haven't already seen it. And this is just the score function that we already have. And that's it. Where's the complexity here, right? As I said, so the two sparse table is going to be n log n, right? That's just sparse table things. It's a black box. I'm just going to keep it that way for now. But for each query, I mean, given k, we have one heap operation, which is going to be O. So, so I think one thing that can get a little confusing is that, okay, well, you may say, how many items are actually in heap, right? Well, remember that we start with one heap item, and then for each operation, we turn one heap item into two heap items. But this is not exponential, because sometimes, I don't know if people do it at home, but I actually do this, so it's not even like I don't know. Like I don't know why my brain sometimes do it this way, but today it didn't, which is good. But because I'm like, oh well, one turns to two, so it's exponential, right? Well, it can be for sure, but no, in this case, because in the worst case, you can say that we pop once and then we push twice. That means that for each k, we have +1, meaning that after k operations, we have at most 2k elements in the heap. And so this is actually not log n, this is log k, right? Which of course is actually, k could be a small number, of course, but k can also be n squared, right? And log of n squared is actually log n, right? So, so I guess that's fine. I don't know. I don't know. So it's still log n, but if you really want to be more precise, it is log k. But in any case, yeah. So this is log n, and then we have some scene operations, which is maybe you could say log n, but these are definitely log n in either case, or log k, depending on how you want to say it. And yeah, and that's it. This is, I mean, the sparse table code you could probably find on ChatGPT or something. So I'm not going to spend too much time on today's problem. It just basically lets me get the max and the min for a given range. And the rest of the code is like 20 lines, right? You can see everything here. I don't think I'm missing anything. And that's with kind of some, a lot of white space. Yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live in a contest now. I could make an optimization, but I didn't want to prematurely, well, I didn't want to spend time on it. That's all. All right, so we are 3 problems in. How are we looking so far? We're 504th, not bad. Now we have to do Q4. All right, Q4 hard, you're given an integer number n and k. Is it the same one as before, except for probably a little bit different? Was it Q2? I mean, I don't think there's anything to learn from just this one statement. Okay, but this one has to be distinct. Okay, that makes way more sense. Okay, so we don't need the other one. All right, so we have to be distinct. So we want to sort or n squared type thing, and they're all Okay, so we just want to be able to sort n square things, but n square is obviously too big, so you can't actually sort of them. Nums is actually things, so it's okay. So I think here, K is only up to 10 to the 5th, so for each number, can we do something with K? Like if we do like a almost like sliding window type thing, if we do a sliding window type thing for each number, we go, okay, if this is the last number, then we get the min or the max to the left side, right? And then kind of put things in kind of thing. How would I write this? And we have plenty of time, right? An hour 15 minutes. I mean, this is not going to be a short one, but that's fine. Okay, so you eliminate, right? We keep track of... No, because you can't even iterate all of them. So you have to keep track. How do you keep track? Okay, so... So this number, right, is either a new max or new min. Okay. As we do the sweep line, okay. And it will generate n distinct numbers, okay. And part of those n distinct numbers, I mean, we still want a heap for sure, okay. But then we also want to do a count of all those things. Well, maybe not a heap, or at least because you still don't want to do n squared. All right. I mean, I think conceptually this one is not that bad, but I am definitely because there is a version of for this problem. I can't remember how to resolve. Which is with the right, because then now you go 1. Okay, if you do 1 over, then it's going to be 2. Do you have to consider all of them? Maybe I have to think about this another way, right? Okay, given this number, if this number is min, how many sequences are there to the left? And then do the same for max. So we just kind of do all the combinations and then just do the math, right? But we don't, I mean, the min is fine. Is there anything with K? K can be pretty big. I mean, it goes up to 10 to the 5th, but essentially pretty big. Okay, I mean, we can definitely change in the universe situation. If K is too small, then what happens? We only care about K things, maybe? Is that true? No, because I don't want to do K square either. If K is too small, then, but only compared to n squared, right? Because we can do a brute force for smaller numbers. How long do people take to do this? Oh, wow. Well, I mean, okay, 2 minutes is definitely cheating, but 7 minutes means people have gotten it pretty quickly. So I don't know. So maybe I am not going that fast today. But the problem is that, okay, no, for each one, there is definitely a thing where this is the max, and then you have to look at the min on the left side. But you have to also get all the other mins, where it's not just the min. It is all the mins going to it. So if you have like 1, 2, 3, then you have to do, and you're doing 3 where 3 is the max, then you have to also do, you have to do one version of the 2 and then one version of the 1, right? So it's not just, you can't just skip to the 1 to get to the min, right? And furthermore, the difference matter. I mean, there's math around it, but I feel like that's really complicated. I mean, I think you can do this math by a lot of like geometry things, but I'm surprised that people could get this so fast, even with cheating. I mean, some people didn't cheat, but so I'm trying to think whether there's like a better, easy solution. Okay, maybe we have to work off Q2 a little bit. So we know that is there like a BFS type thing? Well, okay, so we start off at the biggest sequence, and then we just chop off the left, chop off the right. Is that enough to generate all possibilities? Maybe that's how you can generate it instead of some crazy math that I'm thinking, right? So okay, so you have LR. So inclusive, right? And then you always just chop off one at one of them, right? Yeah, okay. No, that's okay. I see. And then we have a priority queue, which is a heap, right? We want to say H. We want to say okay, just I was trying to think of how not using sig tree, but yeah, sig tree Python. Or even a sparse table, right? I have code for that, hang on. Okay, so this is my store. I got it somewhere. Okay, so we have a sparse table nums. I guess min is fine, and then min sparse table. I guess min and max is still max sparse table. Okay. Does that compile? I forget whether I have to. Okay, well, I am raging, but maybe my code should not be. Okay, that looks okay. So then now we want to push heap. We want to say the score is going to be, okay, let's just say score is equal to 0. We want to say min query of LR max LR minus this, right? And I think you could be a little bit smarter about it, but I think this is fine for me. At least for now. We'll see if that works. Okay, then Q No, this is a min heap. This is the min heap, Larry. All right, so then you want to do. Right. Okay, so then now h, right? So you have negative s, or just s, or is equal to this, and then score we do negative s, and then now we want to push heap this thing. But nope, +1, Larry. Why are you doing? Okay, so this is if L +1 is the inclusive, so we should be, this is fine. And then if R -1 is then this is the I hope this is right. Yeah, I think actually Q2 end up being a hint as a result. I'm going to YOLO submit. Is there 2 ways? No, you can't. You can't, because you can, there's 2 ways to get to the same thing, so you're going to dupe. Okay, so I'm glad I did not submit, but what I have to add is some sort of scene, right? Yeah, okay, and then now, and then now we want to add. Oh, that was close. Okay, is this good? I'm gonna YOLO. If it times out, it times out, but if I get wrong answer, I'll be a little bit curious. Okay. Whew, I almost got this wrong because I forgot the scene part, because I mean, it's based off like a DP type principle, but yeah, okay. I mean, 30th is not that bad. I definitely was a little bit slow, but that's okay. Yeah, and I am obviously talking a lot. That's my excuse. I'm sticking to it. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm, this contest, everything in between. Stay good, stay healthy, good mental health. I'll see y'all later and take care. Bye-bye.